In this playlist, we are going to go through this course, Neural Networks from Scratch in Python by Syntax. What is so special about this course? This course specializes in the visualizations they have included in the course. So, no matter where you are in your learning journey, whether you are beginner, intermediate, or advanced, to understand the concepts, to to have a much better mapping of them in your mind, this course is must. So this is amongst the classics everybody must do because of the quality of the animations which help in the understanding. So you see, whatever concept you might think of, the explanation of it is done in an extremely nice visual format. They are not interactable, but at least their visualizations are seeable. We can see with our eyes, not just read with words. So this course specializes in that, and that's why I'm doing this course. So if you go on my GitHub profile, you can find all the details and everything I'm following here. It's a 7-9 lecture course, and once the first lecture is done, we'll be around a 10 to 12% done, and that's what it is. So let's go to the first lecture. Okay. How you go about studying this is study the original lecture, and as an extra thing to kind of like see even more resources on top of that, you then watch my video. So by doing them in pair, you will get the most out of it. So here in the first thing, what is explained is what is a neural network and what is its fundamental building block. So thing about deep learning is it has just one building block, which is just repeated a lot of times. This is a very special from all other subjects. If you're learning physics, it's not like you just need to know atomic attraction rules of, between proton and electron and neutron and blah, blah, blah. There are so many things you need to know. Whereas in neural network, the root of every neural network is a single neuron. No matter the network might be even ChatGPT. So the building block is so much more important. And by forming the connections of these neurons, we get a neural network. So this is what is explained in the first section of this part, which is how does a neural network actually look like? It looks like this, wherein every single neuron is connected to every single neuron before it. The before part is important. Why? Let's see. This is the first neuron. We already know it's just replicated. So let's pay attention to understanding the first one. This is connected to everything coming before it, and it has different connection strengths. This is inspired from how things happen in our brain. Okay. For example, if we are studying physics and we have studied a lot, so the connections related to physics, those connections in our brain are a lot stronger than the subject we do not know. So if I'm an expert in certain subject and just beginner in certain other subject, the subject I'm not expert at, the connection strength is going to be weaker. And at stronger, it is going to be stronger, and there are going to be more number of connections. So you see here also the thing which we see in colors, blue and red, it is about the direction. Blue is positive, red is negative. And lighter the thickness, it means the value is less. So here for this neuron, which is connected to previous three neurons, okay, it actually multiplies the value present here with the connection strength. That's all a neuron does. Every single neuron does the exact same thing in that neuron. None of the neuron is connected to any other values. They're all connected to the same thing, and they are doing this calculation separately, as you can see when you click on each neuron. When you move next, in the next layer, same thing remains true. The input of this neuron, the neuron in hidden layer number 2, is forms as an output of previous neurons we had. So you see, every neural network kind of like operates like this. The output from here goes to the next layer, and it is multiplied with the weight strengths they have, whatever it may be. So let me just click on new random weights. Every single time the permutation and combination and the values of the weights are going to be different. As you can see, colors are changing. So whatever those connections may be, the input is multiplied with whatever the connections weight strength is here, and then its output goes to the next layer. The same thing continues. That is what is a neural network. And how we define this neural network, it actually kind of like allows us to solve any kind of problem. So these are the two web links where you can actually interact with the neural network. So you can check this animation. So if you go to nnfs.io, the first and second and third and fourth, these four links are related to lecture one. So in this video, we actually see how the connections are formed. So you see, I already mentioned it is all connected to the previous neuron. What we are focusing on here is when we increase the number of neurons, how many connections increase. So you see, here the number of lines are a lot. So as and when number of neurons grow, the connectivity, the lines which have formed the connections, they grow a lot. And that is what this video is actually allowing us to understand. So if I go to this NNSVG, whatever this neural network configuration is, if you check in bottom right, you will find how many neurons are there and how many connections are there. If you want to map what this connection is to, similar to what in our human brain, neuron is one-to-one mapping. You know, this is a basic unit of neuron, and in our brain we have a neuron. And in connection, the connection thing which we have here, in computer it is saved as a simple numerical value. So it's like if it is negative, we kind of like save it negative. And in our brain it is actually connected, and the strength of the connection is, if it is loosely connected, then the signal is gonna not pass through it very strongly. And if it's strongly connected, it's like a highway, and whatever thing we think, we can think a lot faster and better, something like that. Okay. So in our brain, the connection is also called as synapse. And here, this connection is the number of edges you see, and it is called as parameter. It's all about the parameters, which are also called as weights and bias. These values which we are connected to, from the previous layer, each value is a weight. Okay. And if you check in TensorFlow Playground, it's the exact same thing here. Okay. If I just refresh, every time it's going to have a different permutation combination of weights. And depending on how many values we have in input, those many connecting lines weight value is going to be there. And here we can hover and see the variance of the weight here. Blue is positive, orange is negative, thicker the line, if more stronger the value is. So if I train this, you should see some of the values are thicker here because the value is more. Okay. So we have weights corresponding to each input, and there is a single number called as bias. So together they are called as parameters. Okay. Everything in neural network is about parameters and its fundamental building block. When we talk about ChatGPT, people say it is a 30 million parameter model. So what are they talking about? The edges, the synapses, the connections, the weights. The number of those is uh, 150 billion parameters from GPT or something. So this is what a neural network is. Here we are only looking at the internal structure. If we take a look at what this structure represents in a truly real problem solved, it's like this. On the left hand side, if we check, here is the image. In the middle is the model, neural network model, which is going to do the part, whatever it is. And then on the right hand side, we have output. So input layer, hidden layer, output. This is nothing but a complete model here. If you go to visual blocks with google.com, this is a very nice interactive way of looking at these things individually. Okay. So that is a network. It When it executes like this. So we saw this how it grows. Then let's see how it runs. So what happens is, whenever, you know what, we should slow it down. Okay. So what happens is, whenever something happens, The data comes from left hand side and it goes to right hand side layer by layer. Whatever value comes, it is multiplied with whatever weight values are saved at the neuron level. So the input value is multiplied by weight at every single neuron, and that thing which happens, it gives us the result. So that process is happening here slowly. Here, then this, and then finally here. So in the output layer, each neuron is actually a neuron of that specific knowledge. So here, the neuron at the top is specialized for detecting dog, and the neuron at the bottom is specialized for detecting cat. So what happens when any image comes is whichever neuron has a bigger value, most likely the image is of that type. So here, because the output of dog is more than cat, that's why we know that this dog neuron is telling us yes, and it is the neuron we want. So neural network is structured like this. It looks like what we saw with, experiments with Google. How did it look like? And this is how it internally looks like inside. Okay. So mathematically, this is a bit complicated. So you see the same structure we are looking, but we are looking at it in coding format. We are looking at it in visual format. We are looking at it in other applications. So there is NNSVG, which I used and TensorFlow Playground also. It allows you to interact with these things. Okay. More you interact, better you are going to understand. Okay. So this is now the math part. Again, neural networks, every neuron's output goes to the next layer. That is multiplied with the weight values. And that thing is what is being written here. So let's make it slower as well. Okay, so you see here the multiplication of every weight and value is happening. And in programming terms, it is very simple. The input of previous layer is being multiplied to the output. Is multiplied to all the weights of this neuron. So it's neuron number one. That's why it is W1, zeroth index. So this neuron is going to have first index. That's how it is. So it's written in a very simple way. And we understand now neural network in all other formats. So moving forward, in this lecture, when you study here, this is what the neuron is, and this is what the structure is. And then finally, to understand these things, then we go into code. Okay, so do this, interact with the code, understand it, how it looks, and blah blah blah, and then you write your own code, and that code looks like this. A single neuron I want to create, I just define whatever is the input. So if I have 3 incoming connections, I will have 3 values. They could be anything. And we already know that every neuron is connected to every single neuron before it. So because we are going to connect to every single thing here, the total number of weights are going to be 3 also. So if I had 4 incoming inputs, we would have 4 weights. If I had 40, we would have 40 weights. 40 weights are what? Are 40 parameters. And for every single neuron, there is only single bias. This is weight and bias slash parameters of the neural network. What happens in the output of the neuron is simply every input is multiplied to its corresponding weight. So you see, it is gonna be a box like this. So I don't have a diagram which I could draw, but if I could, it would be something. Oh, maybe I could do this. Yes, this is perfect. Let's draw this. Okay. So the multiplication happens block by block. This is the first multiplication. Then we have this is the second multiplication, and this is the third multiplication. Every input index is multiplied to its corresponding weight value. This is what we have simply written here. Okay. And printing the output. So this is what gets covered in the lecture. What is a neural network, understanding its fundamental structure. Because why structure is important? Because this is the structure followed everywhere. First is input layer, then we have hidden layers, and then we have the final output layer. The final output layer neurons, each neuron corresponds to the thing we are trying to predict. So if I'm doing cat or dog prediction, there is going to be a cat or dog neuron. If I'm doing cancer or not cancer prediction, there is going to be a neuron corresponding to cancer and not cancer. So this is how the visualization maps to the any problem you might be able to solve. Okay. So we started with this neural network structure. In maths, what does it look like? You can check in this document. I have used LaTeX to visualize it in mathematical format. And like I said, the first neuron for dog and the last neuron for cat. Okay. And the final part was of the code. Now I'm adding a bit more on top of what was taken here is the libraries which are very common in deep learning. The most common libraries are PyTorch, Keras, and there is one more library, TensorFlow. Uh, I'm not gonna show anything of TensorFlow because right now the most popular library is PyTorch. Okay, so that's why I'm gonna just write the code in this. So in PyTorch, a single neuron looks like this. It is torch.nn. Everything related to neural network in PyTorch is in nn. Okay, and then a single neuron is part of a package called as linear. This is same as called as dense in Keras library. Here it is called as linear. I know this because everything which is fully connected to previous neuron is called as fully connected neuron. The thing which I showed here, the neuron which is connected to every single neuron before it is called as fully connected neuron. But in the name, we do not give it fully connected neuron or layer. Everybody chooses their own name and this is how they're chosen. Okay. So in PyTorch, it has it defines what are the incoming features at every part. So we know that here we are taking three input values. So here in the neuron level, I have to specify the incoming connections in by this name in features. You can find this in PyTorch documentation. And then the total number of neurons here are just one. They are written like this here on in Keras. And here they are not called anything to do with neurons. It is called as out features in PyTorch. Why? Because every neuron outputs a single value. So out features is equal to total number of neurons anyway. So this is how it is written. But when we read, we don't read it as out features. We read it as total number of neurons. In Keras, the API is a bit different. In Keras, it has this name, which is units. So we easily understand units of neurons. So this is a lot better to understand, whereas it is called as out features here in PyTorch. Okay, Keras is easier to read, but it's not as popular as PyTorch. So you should know both. Currently, the code you write in Keras can be directly used in Torch as well. That's why you need to know both, and it will also help your understanding. So one thing different in Keras is it must have a input shape, but this thing need not be part of the layer definition. So if I want to specify what are the incoming connections, this can calculate it automatically. It just needs to know somewhere what is the shape. Okay. So it's 3 input size. I don't know what it is called. Just check the Keras documentation and see what is the parameter name where we specify the size. So I don't know what it is exactly. That's why I wrote it like this. So when I specify the input shape like this, I don't have to say how many incoming connections are there at every layer. Whereas in PyTorch, you have to. This difference is important because this makes reading easier. But when we are calculating parameters or when we want to say how many incoming connections, then we have to, calculate it, look up, what are the incoming things. Whereas in PyTorch, it is present directly in one shot. You can see the definition and know how many incoming connections are to each neuron. Okay. So everything has pros and cons, and this is how both of them work. And this is the entire first lecture. Interact with these things visually. interact with the code, interact with the things which I have given, and then you will have a deeper understanding of lecture 1. And in next lecture, we will go beyond neuron. We will code an entire layer. Okay, see you then.